Hello, everybody, and welcome. Today is the 10th of February, and we are doing lesson 7-7. You want to make sure you have your notebook out, you got it opened up to the very next blank page, and you are ready to go for today's math. We are actually going to add mixed numbers today. Adding mixed numbers is no different than adding regular fractions. So first thing we want to do is take our math problem right here, and we want to stack them. So I'm going to rewrite this 2 6/10 plus 1 3/5. And I know I need to rewrite these as equivalent fractions with a common denominator. So what you want to make sure you do is I go ahead and carry over my whole numbers because those never change. So 2 and 1. Can 5 go into 10? So I start here. Can 5 go into 10? Yes, 5 can go into 10. So that means 10 is my common denominator. And if I didn't know that, I would go off to the side and I would make a t-chart. And I would put 10 on one side and 5 on the other. 10 times 1 is 10. 5 times 1 is 5. 5 times 2 is 10. There is my common denominator. And then we got to rename these fractions as equivalent fractions. So I got 1 3/5 is 1 and some number of tenths. Well, 5 times 2, 3 times 2. That's going to be 6/10. 10 times 1, 6 times 1. That's going to be 6/10. So now I just need to add 6/10 and 6/10 is 12/10, and 2 plus 1 is 3. So my answer would be 3 and 12/10, which is great. The only problem is that fraction right there is a top-heavy fraction. Because that is a top-heavy fraction or an improper fraction, we need to rename that fraction as a mixed number. So when I look at this fraction right here, 10/12, I need to rename it as a mixed number. So you ask yourself, it's a division problem. You ask yourself, how many times can 10 go into 12? Well, 10 goes into 12 once with 2/10 left over. And then I got to take that 1 and 2/10, and then I need to add it to the 3 that I have, which makes my answer 4 and 2/10. Fifths, if you would like to. Um, Reducing fraction is definitely not a necessity, but you totally can. So we could say this would be equal to 4 and 1/5. They are the same. If you type in 4 and 2/10, you type in 4 and 1/5, you should get the same answer. Let's try and do a couple more examples just to kind of get us an idea. This is the news concept today, guys. When you do your addition, there's a good chance you're going to end up with an improper fraction that you're going to have to rename. So we'll get some practice with that. So notebooks out. You're writing down 4 and 5/6. We want to stack them. 4 and 5/6 plus 1 and 7/12. I need to rename these as equivalent fractions with a common denominator. I keep my whole numbers the same, so I bring my 4 straight over. I keep my 1 straight over. Now I want to rename with a common denominator. Well, can 6 go into 12? Yes, 6 can go into 12. That means 12 is our common denominator. Obviously, 12 times 1 is 12. 7 times 1 is 7. That stays the same. 6 times 2 is 12. 5 times 2 is 10. So now I'm going to add. I'm going to add 10/12 and 7/12. That is a total of 17/12. 4 plus 1 is 5. And again, just as a reminder, this fraction right here is an improper fraction. It is a top-heavy fraction. I need to convert that into a mixed number. So 12, I start with my denominator. 12 goes into 17 one whole time, and then I can subtract 17 minus 12. is 5. Oops, yeah. 17 minus 12 is 5. So I have 1 and 5 twelfths. Now I need to take that 1 and 5 twelfths and I got to add it to the 5 that I already have, which makes my answer 6 and 5 twelfths. So that's the idea for today. The biggest thing new is this concept of renaming an improper fraction into a mixed number. Let's do one more as an example. I've got 1 and 7/8 equals 5 and or plus 5 and 1/4. So I want to rewrite these with stacked 1 and 7/8, 5 and 1/4. I am adding these together. I know I need to find a common denominator. Can 4 go into 8? Yes, it can. Oh, there. Now we're on the same page. Can 4 go into 8? Yes, it can. So this 8 is my common denominator. I bring over my 5, my whole numbers. I bring over my 1. And all I got to do is ask myself, 4 times what is 8 times 2? 1 times 2 is 2. 8 times 1, 7 times 1. And then I would just add 7/8 plus 8/8. 7 plus 8 is 9. So this is 9/8. 5 plus 1 is 6. Now I've got that funky looking improper fraction right here that I need to rename. So 8 goes into 9 one whole time with 1/8 left over. And when I do that, I got to add 1/8 plus my 6th, which is going to be 7 and 1/8 as my answer. So overall, not too bad. Nice work. What we might want to do is practice kind of renaming improper fractions. So if you would do me a favor here and just copy down a couple of these problems. Let's say we had 23 sevenths. Well, 23 sevenths is obviously bigger than 1. But how many times does 7 go into 23? Well, 7 times 3 is 21. So that gets us really close. So I'm going to say 3 whole times. And then there's going to be how many sevenths left over? Well, 7 times 3 is 21. 23 minus 21 is 2. So that is going to be 3 and 2 sevenths. So it's really a matter of asking yourself, how many times does the denominator go into or fit into the numerator? So we want to be real careful today, guys. Take your time. If we have any problems, I'll be sure to be checking in periodically throughout the day and then check in periodically throughout the evening. So you are going to go get started. You are going to work independently today. So quietly at your own seats, you are doing Practice Buddy 7-7 and the Quick Check 7-7. All right, you guys have a great day. I will see you tomorrow.